Alright, hello everyone. Welcome back. We are still going to be going over some Pyspark, and in particular we're going to cover some date conversions and extracting times and days and months from datetime objects. I've had a few questions about this, as it seems to be a large component of many of the projects. And working with datetime is always a hassle, so I decided to kind of cover a few useful tricks for you guys to use going forward in the course. So we're going to go ahead and dive in here. We're going to start with initializing our Spark session. We're going to import from pyspark.sql, import the Spark session, import OS, import our config parser, which is going to contain all of our AWS information. And then we're going to create some user-defined functions by importing from pyspark.sql.functions import UDF. So first we need to initialize our AWS, our information so that we can log in. So we have config equals config parser dot config parser, and then we call that by putting our parentheses. We're going to read our config file. In my case, I just have it named in the same directory as config.config. So here I'm just going to go ahead and assign my credentials by saying os.environment AWS access key ID is equal to my configs file with the AWS key, and then I have it named as key. And I do the same thing for the secret password. Let's go ahead and just run these over again here. So here I'm going to initialize my Spark session with Hadoop AWS. So we do our Spark session.builder. We assign to the config parameter, providing the arguments spark.jars.packages. And then the second argument is going to be org.apache.hadoop AWS, and then we say the version type is going to be 2.7.0. Finally, we call .get or create. So the .get or create is, in our case, I'm creating a brand new session. If you're going to be working on an existing one, you would use the .get or create. But in that case, it would be getting a Spark session that you had already initialized before and provided a name. In my case, I'm not providing an app name or anything. I'm just going to be creating a brand new one from scratch. Alright, so now we're going to go ahead. I'm going to load some data from S3. Here we're just going to use the read CSV function that Spark provides by calling spark.read.csv. I'm going to provide the S3A URI with the file that I'm going after, which is payment.csv. And in order to format the data appropriately, I'm going to have to provide that it's going to be separated by semicolons. I want to infer the schema and also maintain the columns by setting header equal to true. This will take a few seconds here, and now we can go ahead and print our schema as well as return the 5 first rows by calling df.show and providing the amount of rows that I want to return. So the print schema, what's returning here is the column names, the column type, and then the if the properties of the column, so if it's null or not, or if it accepts nulls or not. Here, the df.show, as you can see, it's returning a data frame, and then we have our columns up here at the top, and then the values associated with each column. Okay, so as you can see here, our payment date already is in a pretty nice looking date format when we're working with this data, but what I wanted to do was, as in the case of our project, we're working with a Unix timestamp. So what I'm going to first do is I'm going to convert that payment date into a Unix timestamp so that all we have is seconds. So first I'm going to go ahead, I'm going to import from Pyspark.sql.functions. I'm going to import that as F. So to do a conversion, I want to say df payment is going to be df.withColumn. The with column would be basically adding a new column called payment date. And then second, using that SQL.functions, I'm going to apply the function .unix timestamp, and I'm going to be performing that on the column that already exists, payment date. So now when we see that it's run, we went from the payment date up here being a string to now we have it as a long timestamp. As you can see now, it's all just a bunch of seconds, which isn't very informative if you're going to be doing analysis on your data frames. So in order to convert it back into a time that is a little bit more legible for human consumption, I'm going to go ahead and use the same process here, but instead of Unix timestamp function, I'm going to be calling the f.to timestamp and then performing it on that same column. So once again, we're going to say our df payment equals df payment dot with column. So the new column, payment date, which I'm just going to be reconverting it, we say with column payment date. The second argument will be f.to timestamp payment date. And when we run that, we can see that we have converted it from our Unix timestamp here back into a legible date time that will be a little bit easier to work with. Okay, if we were interested in extracting the year now from that payment date, we're going to be, once again, following kind of a very similar process. So we're going to say our df payment, now df payment.withColumn year, we're creating a new one. We're going to say with that column we want to perform the function f.year, which is going to access just the year value from our date object. And then we're going to be working on the column payment date. So now as you can see, what is returned is we have a new column, year, which extracted 2017 from all of the individual rows here. To extract the month, it's as simple as switching up that column, or I'm sorry, that function from f.year to now we are extracting the month. So f.month payment date. We run that, we can see now we are accessing the month, and if we double check, we see that the first row was 2017-01, and now our month is 1, and the same process for every single one of these rows. If we want to extract the day of the week, we can utilize the day of month function. So we got df payment.withColumn. So the new column we're creating, we'll call it day. We want to perform the f.dayofmonth function on it. And then when we run that, we can see that now we are getting our days returned. We have the 24th, the 25th, the 28th, and it looks like everything is working as planned. So as well as the day of month, we also have one called the day of week. So if we're interested in a particular day, so be it Monday, Tuesday, Wednesday, or Thursday, we can switch it up a little bit. We're going to go ahead and do our df payment.withColumn. We're going to call this one day of week. And then we're going to call the f.dayofweek on our payment date. So it's going to extract the day from these datetime objects, and it will return the day of the week, ranging from 1 to being Sunday, 2 being Monday, 3 being Tuesday, 4 being Wednesday, 5 Thursday, 6 Friday, and 7 it will be Saturday. So we can see now what we're getting returned is our individual days. So this will be helpful when we're performing analysis on our objects. So if I wanted to convert those into a string, what I will have to do here is create a dictionary with each of those numbers associated with the day of the week, and then for the values of that dictionary, I will actually provide strings. So as you can see here, I just did some kind of short strings here for the days of the week in my weekdays dic. Now what I'm going to do is I'm going to create a function, well actually a user-defined function from Pyspark by saying converter equals UDF, provide a lambda function. So for lambda x, I want to return weekdays dic x. So it's going to pass each one of these values in the row into the dictionary and then return the value associated with it. So now we can say df payment equals df payment dot with column. We're going to be working on the weekday, or creating a weekday column. And then I want to perform this function, our user-defined function, converter, on the column df payment day of week, because that's the one returning the integer associated with the actual day of the week. So we run that. Now my data frame was getting a little cluttered because of all of the new columns I've added, so in order to kind of hone in on a specific column and make sure that the data is being input correctly, I'm now going to use the .select method. So df payment .select the column that I'm interested in, and then I'm going to call the .show to return those values. And as you can see, we have now converted these values into the appropriate day that they correspond to. So now to extract the hour. Once again, we're going to be calling df payment with column hour, creating a new column called hour. We're going to use the function library of Pyspark, calling f.hour, and then we're going to say payment date. So it's going to extract the individual hour for each date object that we have in that data frame. We call our show method now. We can see what's returned is the hour of the day in military time. So here 0 corresponds with midnight, 8 o'clock in the morning. You know, we have 2100. I believe that is what? Is that 9 o'clock? I don't know. I've never used that before in my life in regular day-to-day, but yes, you can see that we are getting the appropriate values. So this is kind of perhaps a, not the best real-world example here, but perhaps say that we want to actually now have strings associated with these hours. So what I want to do is I want to create a function that looks at the hour of the day, and if the hour is before noon, I want to say that it's morning time. If the hour is afternoon, I want to call it nighttime. So with a lambda function, we wouldn't be able to do this because we have some conditionals. So what I'm going to do first is I'm going to create my own function called time converter, which checks if x is less than 12, we want to set x equal to morning, else we want to set x equal to night. Finally, return x. So now I'm going to go ahead and create my user-defined function. So time to string equals UDF, pass it the lambda. So for lambda x, we want to return time converter x. So it's sort of a function within a function. Now we can go ahead and say df payment equals df payment dot with column time of day. We're going to call our user-defined function time to string, passing it df payment hour. Now what's going to be returned is we pass in these hours of the time of day up here, 21, 15, 21, and now what's returned instead will be strings indicating if it was nighttime or morning time. So we're going to go ahead and create our timetable here. So my output data, this is where I'm going to be writing my S3, writing my Parquet file, I'm sorry, to S3. So if you guys haven't set up a S3 bucket before, let me see if I can dive in here and just kind of show you real quick. It's pretty easy. Let's go to AWS. So if we click here, we get into AWS. Let me go ahead and sign into my console. Okay, so you can go up here, you can go ahead and type in S3, which will bring you to the S3 homepage for that particular service. So it's as simple as clicking here. We can go ahead and create a bucket. You will have to create a bucket name. Many of the standard generic ones that I've tried have already taken, so this will have to be something kind of unique to your particular project that you're working on. Let's go ahead and create one called random123 bucket. Whoops, I can't use capital letters. Bucket name 123, just to make sure it's going to work here. So we do have the option of selecting a particular region. In our case, we've been working with the US West Oregon region this entire course, so I'll go ahead and keep that. I'm not going to merge in any settings from an existing bucket. Let's just go ahead and create this one from scratch. So let's see what other options we have here. So we can keep all versions of an object in the same bucket. We can log request for access to your bucket. We can set tags. There's an option for object level logging. We can record the object level API activity using AWS CloudTrail, but that costs extra. I do not want to be using that for this case. And then we also have an option here, which is actually pretty nice, where you can have default encryption. So as soon as they're stored into S3, they're automatically encrypted, and that's a very handy feature. Let's see what else we have here. Setting permissions. So in my case, I went ahead and I just unchecked this. I wanted it to be completely public. I mean, this is not crucial data for anything, so I don't mind if any public user uses it. So I went ahead and unchecked that, but if you were using this in production, most likely you will definitely want to keep these private. So we can now get our final overview of all of our settings and the region name and so on. So we can go ahead, create our bucket, and as you can see now, we have it listed over here. So I highly recommend that you guys do kind of read through the documentation for S3 and kind of get a good handle on all of the features that are available to you. There's a lot to take in, as I'm sure you guys know after diving in for a month on the AWS section. But it's really crucial to really understand the full depth of all of these products and services that they offer. Okay, so with that said, I'm going to go ahead, dive back over to our Jupyter Notebook. Here I'm going to define a variable which leads to my S3 bucket. So I provide the URI simply by saying S3A : -- and then I provide the bucket name. Here I have a folder I call tutorial. Let me actually show you guys that. So now that we have our buckets created, you would just simply click on the bucket, and then you can click here and create a new folder. And you just click that, you create your folder name, and so on. There's some options here that you can use server-side encryption with Amazon S3 managed keys. I'm just going to go ahead and keep that as default. Okay, so with that said, we've defined our output data path, and I'll explain these two lines of code here. As you will see, I kind of ran into some issues. But what I wanted to do was create a timetable. So what I did was I created a variable, and then I assigned it to our DF payment data frame, and I selected all of the time information that I was interested in. So I put in year, month, day, weekday, and time of day. Then if we wanted to write it to Parquet, which is basically an optimized design for writing all of this information. If you need to refresh on the RDD basics, I will share some resources with you, and you can kind of read in and take a deep dive into the actual fundamentals of Pyspark and these Parquet files. But you would simply call timetable.write.parquet. Here I'm going to pass in my output data, and then I want to actually say the name of the bucket here. So I'm going to be creating, sorry, not the name of the bucket, but the name of the table. So it's output data and time. I want to provide the argument overwrite, which will overwrite the data if it already exists. An optional argument that you can provide is the compression type. So I could have used something like gzip. But as you can see here, unfortunately, due to some version type errors, I have not properly installed Pyspark and all of its capabilities. I get this error. So I'm getting an 0217.parquet file, and I've done some research now, and it looks like the simple pip install for Pyspark doesn't actually give you everything that's needed to access all of the functionality for these Parquet file writes. So as I move forward and I try and solve this, if you guys are working on your local computer and you run into the similar issue, feel free to shoot me a question, and hopefully by that time I will have found a solution. But in the meantime, this code is actually word for word kind of what you will see in your project. We do have an optional partition by argument that we could provide. So it would be something similar to partition by, say we want to partition by the year and the time of day. So this kind of goes into the architecture of our clusters on S3. So what it's going to be doing is kind of single dimensional arrangements of our data so that they're easily accessible based on the year and the time of day. So you would say partition by year, time of day, and then we would call it the .parquet method, providing our output path and so on. Anyways, guys, that pretty much wraps it up. I hope that this is going to be a little bit helpful for you. I know that a lot of you guys are struggling with the date time conversions and stuff. Don't get overwhelmed. I know that when you do some Google searches on how you work with date time on the internet, there seems to be a million different methods, but luckily Spark has these functions kind of built into it from our SQL.functions library, and then we can just simply call f.month and f.day of month and easily access all of this information. Anyways, I hope everyone is doing great, and like I said, I'm available on Slack. Please feel free to reach out if you need any assistance, and I'll be sure to get back to you as soon as I possibly can. Anyways, take care, everyone.